Hello, this is Dr. Oz. In this video, I would like to talk about continuous probability distributions. I will cover uniform probability distribution, triangular probability distribution, normal probability distribution, and exponential probability distribution. So let's get started with uniform probability distribution. So uniform, as it states, its probabilities should be the same. Probabilities are the same, so they should be equal. So in an example, random variable x representing the flight time of an airplane traveling from Chicago to New York. And you can write the probability distribution for this example with this density function. So what's the probability of, let's say, we will reach from Chicago to New York between 1 hour to 2 hours, right? So that could be an example, all right? So let's take a look at a visualization of this. Looks like the probability of flight time from Chicago to New York is between 120 minutes to 140 minutes. So back to my previous example, probability of ending up between 1 to 2 hours is pretty much zero, because it takes at least 2 hours and most 140 hours. So this is a continuous distribution because time is continuous, and we could have partial number of minutes. It doesn't have to be integer. So that's why it is not logical to ask what's the probability of having flight from Chicago to New York to be exactly 130 minutes, because then you're asking what's the area for this line, but the area for this line is very close to zero. In fact, any line, let's say probability of this line is also pretty much zero, because there are infinite number of lines between 120 to 140. So that's why we rather use what's the probability of the area between, let's say, 120 and 140, and this is the highlighted area, and that is easy to answer because we can multiply 1 over 20, which is the height, times number of minutes between 120 till 140, which is 140 minus 120. So 20 times 1 over 20 will give you 1. That makes sense, right? The probability of having a flight between 120 and 140 is exactly 1, because those are all the possible situations. So, but not necessarily I will ask whole thing. I could ask, what's the probability of having a flight of 30? Basically, I'm covering, as you see here, this 10 minutes out of 20. So the area for this rectangle is 1 over 20 is the height, and the length is 120, 130 minus 120, which is 10. So 10 times 1 over 20 will give you 50% chance it will end up here, another 50% chance it will be between 130 to 140. All right. So so this is how we calculate the probabilities. Then given given the location, let's say in this case 130, lower bound, location minus lower bound, in the example 130 minus 120, which is 10, divided by upper bound, which is 130 minus lower bound, which is 120, 140 minus 120. So for this example, again, this would have been 130 minus lower bound 120 divided by upper bound, which is 140, minus lower bound, which is 120, which would give you 10 over 20, which is 1 over 2, which is 50%, or 0.5. Okay, that's how you would calculate the probabilities. So the expected value is you add the upper bound and lower bound together and divide by 2. For our example, this would have been 140 plus 120 divided by 2, which is 70 plus 60 is 130, right? That's the average. So on average, you expect this flight to be 130 minutes. And we could calculate the variance by this formula. I mean, I could go in details of how to come up with this formula, but I don't think as business major, you have to know that. So the variance which is a variation from the mean, is going to be upper bound, which is 140, minus lower bound 120 squared divided by 12. So you see 20 times, this is going to be 20 times 20 divided by 12. So if I divide this by 4, it's going to be 3. If I divide this by 4, it's going to be 5. So 100 divided by 3, which will give you 33.3. So that's going to be your variance, and your standard deviation will be somewhere around 6 if I take square root of this. Okay. Okay, so let's go to the next video, which is gonna be about triangular distribution. Until next video, enjoy business analytics.